Welcome back, everyone. I am absolutely thrilled to have you here for today's explainer because we are doing something a little bit different. We aren't just talking about abstract concepts today. We are stepping right onto the factory floor for an active, fast-paced technical field demonstration. We're looking at industrial artificial intelligence in action, where decisions are made in literal fractions of a second. And we're going to break down exactly how those micro moments translate into massive return on investment. If you love seeing how cutting-edge cloud technology orchestrates heavy physical machinery in real time, you are absolutely in the right place. Let's get into it.
Section 1. The need for speed. Manual inspection is obsolete. Okay, let's dive right into this and instantly drop onto a high-speed bottling line. It's loud, it's chaotic, and most importantly, it is incredibly fast. For decades, the biggest bottleneck in a facility exactly like this one was just the human eye. We relied on manual inspection to spot defects, ensure quality, and pull bad products off the line. But imagine bottles flying past in a continuous, unyielding stream. And this number tells you exactly why that manual method is completely obsolete. 1,000. That's how many units are flying down this conveyor belt every single minute. Try to even wrap your head around what that means. At 1,000 units a minute, the product is practically a blur. If a cap is slightly cracked or a label is misaligned by a single millimeter, human inspection is just completely impossible. You can't catch a micro-defect when you're processing over 16 items every second. The line moves too fast, fatigue sets in instantly, and costly errors slip right through. So how do we solve a problem that moves way faster than human perception?
Well, we solve it with specialized hardware. We've got this physical camera inspection setup hovering right over the line. What we have here are GigE cameras paired with these intense blue LED ring lights. And that blue LED is absolutely crucial. It provides incredibly sharp, high-contrast illumination that essentially freezes the motion of each bottle as it rockets past. These GigE cameras are capturing crystal-clear macro shots of every single unit, creating a massive, continuous pipeline of visual data. But capturing the image is really only half the battle. You still have to analyze it. And that brings us to the brain of the operation. The exact second that GigE camera snaps the image, GCP Visual Inspection AI takes over, and it does its job in under 10 milliseconds. Think about that for a second. In less time than it takes a hummingbird to flap its wing, this AI model analyzes the high-resolution image, scans for microscopic anomalies, and determines whether that specific bottle is perfectly sealed or defective. 10 milliseconds to guarantee quality at 1,000 units a minute. It's wild.
Section 2. The 10-millisecond catch. From detection to rejection. So we know the AI is lightning fast, but honestly, knowing a bottle is defective doesn't mean a thing unless you can physically get it off the line before it reaches the packaging stage. Let's break down exactly what happens in those crucial fractions of a second when a cracked cap is actually spotted by the system.
To really understand how the physical action happens, you need to know what's powering it locally. Look, if this camera had to send its image all the way to a distant cloud server, wait for the AI to process it, and wait for the signal to come back, that defective bottle would already be boxed up and on a delivery truck. That latency is a total deal breaker. Enter Google Distributed Cloud Edge. This is localized cloud computing sitting right there on the factory floor. It enables hard real-time AI processing without the round-trip latency. The brain is literally standing right next to the conveyor belt.
Now watch this sequence unfold. It is absolutely incredible. Boom. Step 1, the vision model instantly detects a cracked cap. Step 2, in that exact same breath, Manufacturing Connect Edge translates that AI inference and fires a hard, real-time electrical signal. Step 3, that signal hits the Siemens PLC and wham! The pneumatic rejection arm instantly fires across the belt, physically punching the defective unit off the line and straight into the scrap bin. 1, 2, 3. Detection, transmission, rejection. A perfect, seamless symphony of cloud AI and heavy industrial machinery reacting in under 10 milliseconds.
Part 3, Real-Time Cloud ROI, Closing the Loop. It is thrilling to watch that mechanical arm in motion, but deploying this technology at scale is really about how these rapid-fire millisecond actions aggregate in the cloud to generate massive, quantifiable business value and return on investment.
Because every time that pneumatic arm fires, it's not just a physical event, it is a critical data point. The moment that defective bottle is rejected, the manufacturing data engine springs into action. This engine takes the quality telemetry, what went wrong, exactly when it happened, what the defect looked like, and synchronizes it directly into high-speed BigQuery dashboards in real time. Floor managers aren't waiting around for an end-of-shift report. They are watching their production quality metrics update live as the conveyor belt hums along.
And this brilliantly illustrates the true power of a connected cloud ecosystem. Because that synchronized telemetry sitting in BigQuery isn't just for human managers to analyze. No, it is instantly routed right back into Vertex AI. The AI model is literally learning from its own catches on the fly. It uses the visual data from every single rejected bottle for continuous training. The model just gets sharper, smarter, and more accurate by the second, all with absolutely zero downtime on the manufacturing line. The factory gets smarter while running at full speed.
Now, what's really interesting about all this data is the final result of that real-time processing and continuous learning. It leads to a massive drop in waste. When you combine those GigE cameras, Google Distributed Cloud Edge, and Vertex AI continuous training, you aren't just catching mistakes, you are fundamentally optimizing the entire manufacturing process. That live telemetry allows engineers to fix upstream mechanical issues instantly. The data shows a staggering 35% drop in the overall scrap rate after the AI was deployed. That is a 35% reduction in wasted materials, wasted time, and lost revenue. That is hard, undeniable ROI delivered in milliseconds.
So, the absolutely crucial point we've seen today is that modern industrial AI is no longer just some theoretical concept living in a distant data center. It is a hard, fast, physical reality operating at 1,000 units a minute. We analyzed exactly how it spots the defect, fires the mechanical arm, updates the analytics, and retrains itself all in the blink of an eye. Which leaves us with this. If an AI model can detect, react to, and learn from a single microscopic cracked cap in under 10 milliseconds, what unseen inefficiencies could it catch and optimize on your floor? Think about the speed of your own operations. Until next time, stay curious, keep learning, and keep optimizing.